For this problem, in number 46, it says that a bag contains 6 cherry, 3 orange, and 2 lemon candies. You reach in and take 3 pieces of candy at random. What is the probability that you have at least 2 orange candies? So what we're going to do is start with probability of at least 2 orange. Now there's only 3 that you're selecting, so you must be either selecting exactly 2 orange or exactly 3 orange. So what we're going to do is we're going to take the or statement and make it into an addition problem. So probability of exactly 2 orange, we'll calculate that, and then add to that the probability of getting exactly 3 orange. So how do we calculate the probability of exactly 2 orange? What I did over here was I looked at what kinds of candy do we have and how many of each. So there are 6 cherry, 3 orange, and 2 lemon. And this is all about getting orange candies. So what I'm going to do is I'm going to say there's 3 orange candies, and there are 6 plus 2, which are 8, that are not orange. And that makes 11 candies total. So now, probability of getting exactly 2 orange, we can say out of the 3 orange candies, we want 2 of them to be orange. And out of the 8 remaining candies, we're going to select 1. So, and I should have said we're going to select 2 here. So 2 from the set of 3 orange and 1 selected from the set of 8 that are not orange. So we're going to calculate 3C2, multiply that by 8C1, and then we'll divide that by the total number of candies that we have and the total number that are being selected. So that's 11C3. So when I calculate this part, 3C2, I can put that into the calculator and get 3. 8C1 is 8, and 11C3 is 165. So I've got this part. Now let's find the probability of exactly 3 orange. If we're getting 3 orange, that means there has to be none that are not orange. So we want, out of the 3 orange, we want 3. Well, there's only going to be one way to do that. We have to select all 3 orange. Times, from the 8 not orange, we want to select none. Well, there's only one way to do that, which is just don't select them. And then we divide by 11C3, which is still 165 from over here. And now I can say 3 times 8 is 3 times 8 is 24. 1 times 1 is 1, and 24 plus 1 is 25. So I did that there. So that's 25 in the numerator and 165 in the denominator. I can simplify that to 5 over 33, and if it says to round to the nearest 10,000th, so that would be 0.1515. Now let's take a look at question 47, which is similar but not exactly the same. Okay, so here again we have 6 cherry, 3 orange, 2 lemon, but now we want to get 1 cherry and 2 lemon. All right. So, in order to calculate this, I'm going to look at how many cherry are there. Well, there's 6 cherry. So out of the cherries, there's 6 cherries, and we want to get 1. So that's going to be 6C1 times, and now we want to look at the lemon. we want, let's see, there's how many lemon candies? 2 lemon candies. Okay, so we have to get both lemon candies. So 2 lemon candies, and we're selecting 2 of those. And technically we can say how many orange are there. There's 3 orange, and we're selecting none of those. But since this is going to turn out to be 1, if you skip it, that's perfectly fine. In the denominator, again, we have how many that candies that we have to select from. That's still 11. And we're still selecting 3 total. So we know that 11C3 is going to be 165. All right, so 6C1 is 6. 2C2 is 1. 3C0 is 1. And the denominator is 165. So we have 6 over 165. And that would be, let's see, 2 over 55, which is 0.0364. And that's how you do those problems.